So today I'm going to quickly cover formatted printing. This is going to be particularly important in, after we run a simulation and get information, we want to be able to print out the data and send it to some sort of output file. So that way we can do analysis on the results of a simulation or the results of a calculation. So let's get started. As always, we're just going to go ahead and make a program. I'm going to call it print.f90 for our source code. We'll go ahead and write our program. Implicit none. And we'll go ahead and make a real variable, call it A. And we're actually going to make a few, so we'll do A, B, and C. And all this is going to do when we have 3 letters and they're in the same line as the real, it's going to assign that type to all of them. And we'll go ahead and make this a kind equals 8, make it store a little bit larger of a value. So let's make these values, I don't know, something like this. Okay, so we have 3 values, and we can just do a regular print statement just to see what that looks like. So we'll go ahead and compile it using Fortran. Okay, execute it. And here we go. So we get, previous videos I covered what you need to know about precision, or at least an intro to that, because we see at the end of these numbers some round off error, but we're not going to worry about that too much for now. We're just worried about printing. So this is just the standard format that it's going to do. But what's important is we want to be able to organize what we print out so it's easy to understand in the future. Okay. Before we go to the formatted printing, I'll go ahead and show, though, just a basic way to get whatever your code is going to put out into some sort of output file. So instead of actually writing to an output file inside the Fortran code, we can just simply do it from the command line. So if I come back up here, I have my code that I'm going to execute, and then I'm just going to give it this larger than bracket, and it's called piping. So we're going to quote unquote pipe the output, the print statement, to some other file that we'll call, I'll just call it print.out. And so as you might expect, instead of now it's printing out to the screen, instead it pushed everything into the output file. So let's go ahead and look at print.out real quickly. And there you go. Just exactly what you'd see on the output. But now, exactly what you'd see on the printout statement. But what we want to do is we want to format this printing so that way we can, look at it as a CSV file in the future. So let's do that right now. Okay. So, okay. Let's go back into print.f90. And as the source that I'm using for this video, I think this is really good. This is a website that's set up by Professor Vasilios Alexiades, and he's got just several Fortran tutorials, but this is a really, I think this is for Fortran 77, but it's just a succinct way of explaining how to do the different print formatting. Specifically, I like this style down here that I'm going to show. So basically, we're going to have a print statement. We're going to have, if we zoom in, we're going to have a single quote. And then we have just some strings, some characters that we're putting in. Then we have our first sort of formatting style, which is a F6.2. And I'll go over in just one second what that is. But that F6.2 corresponds to the first value once we're outside the quotation here. And then so on and so forth. Okay. And what do these mean? So the large capital letter corresponds to what we want to print it as. And if we come up here, we see F would correspond to a float. I would be an integer. E would be in the exponential form, so scientific notation. D would be for double precision. A for characters. And then we can also put in some blanks, which just help us space out the print. And the second letters put how many, if it's for basically how many spaces do you want to allot to printing out that number. So here he has just some examples. So we have this stored value of 1.23457. We want to print out 8, and we want 2 after the decimal place. And it gives an output like this, and these caret symbols are there if they're unused positions. So we've given 0.2 for 2 after, and then 8 in total. So if there's 2 after there, it would be 6 in total. So it only needs 1, 2, 3, 4. It only needs these 4 slots, so it has these extra spaces here. And in the inverse, if you haven't specified enough, it'll print out all stars for that. So let's just see some examples of that real quickly. So instead of the print star, we'll have our single quotation, and then we'll have double quotation for A equals. We'll do a quote. We'll do a float, and let's see here. So if we want to capture all the numbers here, we'll do 2 after the decimal, so 0.2, and then there's 5 in total with the decimal, so we'll do 5.2 here. Excuse me, at the F. Okay, so let's do that now for the other ones. Let's see. So we'll cap it with that single quote to say what's the string, and then immediately following that are A, B, and C. So again, this A, if we kind of match what's going on in this here, our A will correspond, we'll drag it over here to this 5.2, B will come here, C will come here. Okay, so let's see what that looks like. Let's try compiling. And it looks like we have an error, so let's see here. Well, I didn't put, it needs to be inside a parentheses. It's an easy enough fix. I do these videos live, so I don't have to spend time editing them. So that's why, but I figure we're all kind of learning this together, so to speak. And it might be good to see some of these errors. All right, let's try again. All right, cool. Let's print it. And there we go. We get 12.34, B equals 56.78, and C equals 99.11. So let's show just an error of let's just show what happens when we give too much space. So we'll come over here and we'll give 10 spaces for F10 here. Okay, and oh, that's right. So he gives the carets just for our visualization, but what actually happens is just it prints out these extra spaces. But these are extra spaces in the sense that, you know, if you later on we'll show importing this information into pandas or something, and pandas sees these just as extra character spaces. So let's see the opposite now. What happens when we give too little? So remember, we gave 5 spaces. Let's go ahead and give 4 spaces. Okay, and then we get this star, star, star. Okay, so that kind of gives an overview of that. But for this first set of simulations that we're going to do, we're going to just need to print out basic CSV files. So the only thing that we want to go ahead and add into this is we want to go ahead and add in a spot for the actual a spot for the actual comma here. And a CSV file stands for comma separated value. And that's just going to allow us to print out spatial coordinates and momentum coordinates and values of conserved quantities like energy. So we just add these in between here. So let's see if that works. Okay, I didn't change the change this one to have enough. There we go. So we have A equals 12.34, B equals 56.78, C equals 99.11. Okay, great. And if this was actually a CSV file, we wouldn't want that. We wouldn't want the A equals. We would want just an initial line that tells us what the columns are. So we can just do, let's just do, and then ABC, and then let's get rid of the actual A equals. We just need the separation values. All right. There we go. So if we uploaded that into, say, like a pandas data frame, something in Python, we could easily read that in and get what the each column is for. Okay, that's where I'm going to end today. Next time, I'm going to outline the different kinds of control. Well, before I end, I guess all I should say is the rest of the different data types operate the same way. You're basically going to tell it what type you're printing and then how many spaces. So I won't go and show an example for each one, but I think this website does a good job of explaining it. And there are other ways to do print formatting. For example, he gives this style here, which is print 200 miles per hour and force. So these are the two types of, these are the two data that we're going to try and he wants to print. And this 200 is a go-to statement. So it's going to go to line 200. So we'll talk about, or line label 200. And we'll talk about that. But then we have the format command, but we see basically the same style here, a 4x, so 4 spaces, and 2 spots for an integer, 15 spaces, and then 10 spots total with 1 decimal place for a float. Okay, so I think I'll end it there. Next time I'll talk about the different control structures. And once we have the different control structures down, we'll go into just some first simple 1D simulations of uniform constant acceleration. Okay, thank you very much.